All right, 2.1, working with quadratic expressions. Here's an example of a quadratic expression that is something called factored form. And the idea is that you could be asked to expand this particular expression and simplify it. So how would you expand an expression like this? Well, what you would do is multiply a times c and get AC. Multiply a times d, you get plus AD. Multiply b times c, you get plus b times c, which is plus BC. And multiply plus b times plus d, you get plus BD. So this is how you would expand, and then you would simplify this expression to collect like terms. So let's look at examples that refer to this. Now, keep in mind, you may have learned this as an example of FOIL, where you take the first terms, that is these terms right here, A times C, and then outer terms A times D, inside terms B and C, and last terms in each set of brackets is B times D. And that is, we use first, outer, inner, last to expand, to describe the process of expanding. So, let's expand and simplify the following expression. 2x plus 5 times 3x minus 4. How do we expand this? Well, we take 2x times 3x, and that gives us 6x squared. 2x times minus 4, that gives us minus 8x. Then plus 5 times 3x is plus 15x. And then finally, plus 5 times minus 4 is minus 20. So you get 6x squared plus 7x minus 20. Why is it plus 7x? Well, we can collect like terms for minus 8x plus 15x. So these two we can collect the like terms to give us 7x. Let's look at the next example. Here we go, a little bit harder. And what do we do with a question like this? Well, hopefully you're thinking, okay, I know what to do with the double set of brackets, but what do I do with the negative 3? Well, that's exactly what you'll do, is leave that negative 3 alone and expand these two sets of brackets. So you will have 4x times 3x, which is 12x squared, plus 4x, plus 6x, plus 2. Once you've done that, you then collect the like terms of the middle terms, and you get 12x squared plus 10x plus 2. And then what you'll finally do is take that negative 3 that's on the outside and multiply it to every term on the inside, so that you get negative 36x squared minus 30 minus 6. And this here is the expansion of this expression. All right, let's try another one. What about 4m times 2m minus 5 times m minus 7? What do we do here? Well, hopefully you're thinking, yes, that's right. We have to expand these inner two sets of brackets first before we multiply 4m out. So we get 4m times 2m squared minus 14m minus 5m plus 35. So that's expanding again. And then minus 14m minus minus 14m minus 5m is minus 19m. And once we collect those like terms, we can now multiply out that 4m. So 4m times 2m is 8m cubed. 4m times minus 19m is minus 76m squared. Plus 4m times 35 is 140m. All right, and that's the end of that example. We've got one more to go, folks, and a little bit harder this time, a little more complicated, and just to show you what we have to do for this. First of all, let's treat these as two separate entities. Let's look at the first one right here, 4x times 3x minus 2. What do we get when we expand that? Well, we get 12x squared minus 8x. Now, that second part over here, we have a negative 2 times a double set of brackets. so leave the negative 2 alone. Expand out the double set of brackets just like we've been doing all along. We get 6x squared minus 2x plus 9x minus 3. And what we're going to do is expand again, leaving the red alone, just the way it is, but multiplying this negative 2 into, first we're going to collect like terms here. Let's collect the like terms. And then once we've collected the like terms, that's minus 2x plus 9x is plus 7x. We're going to multiply the 2 into each piece here so that we get 12x squared minus 8x minus 12x squared minus 14x plus 6. And then we finally collect all the like terms, and we have 12x squared minus 12x squared. That's 0x squared. 0. That means gone. Do not put in x squared at all because it's gone. Minus 8x minus 14x is minus 22x, and then the plus 6. So that's it, folks. That's the answer to that complicated question that looks so hard. All right, well, that's the end of 2.1, folks. Have a numerical day. Take care.